So now we'll discuss about the linked list. So linked list is a linear data structure, so which includes a series of connecting nodes. So it is defined as the nodes that are randomly stored in the memory. So the last node of the list contains a pointer to null. And after array, linked list is the second most used data structure. So in linked list, every link contains a connection to another link. So this is the representation of linked list. So there will be data link, the value will be there, and the address of this will be given, and first is the head and last is the tail, and the data and link combined is known as the node. So there are different types of linked list. So first is singly linked list. So it is defined as the collection of ordered set of elements, and the node is singly linked list. It has two parts, data part and the link part. So data part of the node stores the actual information that is to be represented by the node, and link part of the node stores the address of its immediate successor. So this is the diagram for this singly linked list. So the next and the last will be null. Doubly linked list. So the doubly linked list is the complex type of linked list. So here node contains a pointer to the previous as well as the next node in a sequence. So doubly linked list node contains three parts: node data, pointer to next node in a sequence, that is next pointer, and the pointer to the previous node, that is previous pointer. So you can see in the diagram that is first, last, and then next pointer, and the previous pointer is given here. And the major operations and the descriptions is given. So insertion at the beginning. So adding a node is insertion at the beginning. The insertion at the end is adding the node into the linked list at the end. Insertion after specified node, that is adding the node into the linked list after the specific node. And deletion at the beginning, so removing the node from the beginning. Deletion, that is removing the node at the end of the list. And deletion of the node having given data, so removing the node which is present just after the node containing the given data. Searching, that is comparing each node data with the item to be searched. Traversing, that is visiting each node of the list at least once in order to perform some specific operations. So insertion, so the algorithm is given here, that is step 1. If pointer is null, write overflow and go to step 9. So in step 2, set new node, that is a pointer, and step 3, set pointer, that is pointer points the next value, and then set the new node data to the value, and the new node previous to the null, and new node the next to the start of the insertion, and set head to the previous as a new node. So setting the head to the new node, and then it will exist, so it will insert the new node. Deletion is in the doubly linked list at the beginning as the simplest operation. That is, here we can see the algorithm. So if head is equal to null, then write underflow and we can go to last step 6. So or it will move to next step, that is set pointer as head, and set head is ahead as ahead is the next step. So next, so step 4, that is setting the head previous to the null value, and then free the pointer. So if the algorithm process like this, we can delete the particular node. Advantages of doubly linked list. So reversing the doubly linked list is very easy, and it allocate or relocate the memory easily during its execution. And deletion of nodes is also very easy as compared to singly linked list. And disadvantages is it uses extra memory when compared to array and singly linked list. And advantages of whole linked list is it is a dynamic data structure. Insertion and deletion is easier, the memory efficient, more memory efficient. Implementation is when compared it is easier. And disadvantages is memory usage, so more memory usage than array. And traversal is not easy in the linked list, so we have to access an element in the linked list, so we cannot access it randomly. And reverse traversing, that is backtracking, is difficult in the linked list. Next is the circular linked list. So here we can see that the last node of the list contains a pointer to the first node of the list, so it will comes like circular point. we traverse a circular singly linked list until we reach the same node where it started. So that is the circular linked list. Applications of linked list. So linked list is used in many things. That is, it can be used to represent the sparse matrix. It can be used to implement stack, queue, tree, and other various data structures. Used to implement dynamic memory locations. Used to represent a graph as an adjacency list. So there are various advantages of linked lists.